check. Oil pressure, check. We have clearance. Okay, Jack, let's get this baby off the ground. So here we have a diagram showing the gain in weight from that first cell, the union of the egg and the sperm, as it multiplies and grows and finally develops into a full-term baby. And so the red area is showing the weight at the various stages, the ages of development from the time of conception. And so first thing to mention is that at 6 weeks on ultrasound we can detect the fetal heartbeat. And so that means blood is already there for the heart to be pushing around. Then organ formation is mostly complete. It's totally complete for some organs, not the size, but the formation. The asterisk is there to remind that the brain is not complete until actually finished growing physically in size until age 8 years. And so that's why you notice that the children have a smaller ratio. The chest, the thorax, the trunk, in relation to the head is smaller. The head's bigger, and then after the head stops growing at age 8, then the rest of it catches up. And so that's why there's that difference in the proportion. Now that's the physical size of the brain. The interconnections inside the brain don't actually finish until about age 23 or 24. And that explains why we have brainless teenagers. Then at about 18 weeks, now that one my wife can still laugh at because we went through it 3 times. So she's heard these many times. So at about 18 weeks, then the mother can feel the baby kicking or moving the arms, and that's fetal movement. The old-fashioned term for that is called quickening. And it reminds me of one patient I had, a teenage girl who came in complaining of abdominal pain, and her mother was there with her. And see, the girl's about 15 years old. And I said, well, describe the pain. And she said, well, it feels like I'm being punched inside. And indeed, she was. She was pregnant. So she gave a very good description of that pain. So she was feeling the quickening. Then the lungs become functional around 32 weeks. Prior to that time, they're not mature enough to do the job of breathing until about 32 weeks of development. And after that, even though the baby may still need some ventilatory support, but usually by that time they can function just with some oxygen supplementation. All right. Then the key thing here, a major change, a major development is around 12 weeks or so, 13 weeks of development, about a third of the way through the whole process, the placenta has now finished developing and becomes functional so that it can then take over the job of providing everything that is needed for that developing baby. Prior to that time, everything is happening just by simple diffusion from the tissues that line the uterus. And then the placenta takes over. So we're going to be talking about that whole process. So this is a representation of the lining of the uterus, and the technical term is endometrium. And you see there a representation of tissue sloughing off, representing the period, the menses that happen. And so menstruation is the more technical form of that word. And then there's the phase of the rebuilding of the tissue lining the uterus, and that it grows back to full thickness and is lush in its ability to provide secretions to nourish a developing embryo as it comes along. And so that is under the influence mostly of estrogen. So then you see there the representation of ovulation when the egg is released from the ovary and then travels through the tube called the fallopian tube to the main body of the uterus. And if that egg is fertilized, then there are a lot of chemical interactions that cause it to stimulate the lining to remain lush and be able to support the pregnancy. And that is under the influence of estrogen and a second hormone called progesterone. And the word progesterone, pro meaning for, and gestation, gestation means the actual development of the baby. So that hormone is responsible for supporting the pregnancy through keeping that lining of the uterus, the endometrium, very lush and secreting the support that's needed. So that's called the secretory phase. So with fertilization, that occurs, the progesterone is present, and then implantation occurs about day 5, day 6 after fertilization. And then it starts invading and taking over the tissue, the lining of the uterus. So this is the overview here. And so now we'll go into some detail of what happens with fertilization and implantation. So here is the egg, and it has one set of chromosomes, and when the sperm comes along, it will provide the other set, so that there are 2 sets of chromosomes. And you see those 2 black dots at the bottom, those are called polar bodies, and you're going to see that they will change their position as we go along here. This zone around the egg is called the zona pellucidum, and it's a proteinaceous material, and it's like a protection, providing a barrier that the sperm are going to have to get through in order to get to the egg. And there are these special nurse cells that tend to the egg and make sure the egg gets everything it needs, brings along the secretions and the nutrients. And they form what's called the corona radiata, meaning the crown that surrounds the egg. And there are those 2 polar bodies I mentioned that are going to shift in a bit here. So here is a diagrammatic representation of the ovary, which is what produces the eggs. And then this egg has been released, so ovulation has occurred. Those fringy finger-looking things there on the end of the fallopian tube are called fimbriae. And so they move, and they are beckoning the egg, come on, come this way, to get into the tube, so that the egg can then travel through the tube to get to the main body of the uterus. So now the egg is in the tube, and so now insemination has occurred. The sperm have traveled through the female reproductive tract to get to the egg. They've traveled that whole length. And so now I put the one of the sperm there in red versus the other ones in white to say that that's the one that got there first, and that's the one that's going to fertilize that egg. And once it makes contact with that egg and penetrates that barrier, then a chemical reaction occurs to prevent any other sperm from getting in, so that there's not an abnormal number of chromosomes. So that there's only 1 set from the dad and 1 set from the mom. So now it shows that that one has gotten in, and you see that red, thin red circle around the green circle. That's that barrier that occurs so that no other sperm will get through. And then there is now the set of chromosomes from the dad and the set from the mom. So then they come together, and then the polar bodies move around so that they're at opposite ends, like a north and south pole. And now these chromosomes are set up so that they have multiplied, they've reproduced themselves. So now there's going to be a second set, so that now this divides, and now there are 2 cells. And so each cell has the full set of chromosomes that the original fertilized egg had. And the technical term for the 1 cell state there is zygote, and the word zygote means yolk, meaning union. Y-O-K-E, not Y-O-L-K. Otherwise you have egg on your face. So then notice that these cells, 2 cells, occupy the same volume of that first 1 cell, the zygote, so they're half the size. And then when it divides again now, they're each 1/4 of the size. So the cells are getting smaller and smaller now. And what they're going to do is, after enough multiplications and divisions, they're going to actually come down to the normal cell size, because the egg is quite unusually large. So there is still that clear zone around it, And so now the egg is being moved along through the tube by the little whip-like appendages on the cells lining the tube, moving it along, going like this. And so the egg is then moved into the main body of the uterus. So here you see now the cells inside have been multiplying, and now you see they're much smaller, and there's now differentiation. The ones that are yellow are going to become the baby, and the ones that are more of a purple color are going to become the placenta. But all of this comes from the chromosomes from the mom and dad. None of this comes from the cells that are the mom's cells herself. These cells are distinctly different. They're genetically different because they're half of the genetic materials from mom, half is dad. And that brings up the issue that these days, a lot of these folks want to say, well, it's my body, I can do whatever I want with it, and I can have an abortion. Well, this is not really true. It's not genetically true, because even though this new developing individual, fully human, is inside mom, it is actually not part of mom and is distinct from mom, totally different genetically. So now you see that label, trophoblast, and that means germ feeder. Germ in the sense of the germ as in the beginning of a new being, a beginning of a new organism, not germ in the sense of some bacteria causing a disease. And so we have this inner cell mass that's going to be forming the baby, and now it moves, it rotates so that it will be in position to be directly opposite the lining of the uterus as it will be moving around. And so now you see these secretory glands in that lining of the uterus are now providing the nutrient for the developing embryo. And so it finishes rotating so that it's in its proper orientation. So now it is going to do what's called implantation and invasion. And so invasion here. So now what's really fascinating is that these purple cells develop, but they don't stay where they are. Instead, they migrate out and they start fusing with each other, combining. So each of those little black dots you see in that white area are the nuclei from all these cells that have fused together. And they're forming this huge mega cell. And you can see that as it comes along, it's going to get bigger and bigger. And so you see cytotrophoblast, so now that purple layer means cell germ feeder. And then syncytiotrophoblast, for that white area with the dots representing those nuclei, means fused cell germ feeder. Fused cell germ feeder. And that perfectly describes what it's doing. And so you see more and more of those cells multiply and fuse together. And you can see now it's beginning to totally surround that purple layer. And indeed, that's what it does. So that white thing is one monster megacell that totally surrounds. Now remember, you're looking at 2 dimensions, but this is in 3 dimensions. So it forms a total sphere around the developing baby, and that's going to be another layer of the placenta. Now, I'd like to have someone explain to me how this evolves by evolutionary random chance events. Okay, it's just simply not possible. So inside, that inner cell mass is now starting to differentiate and form what's going to be the actual baby and what's going to form some other parts that will be specialized. Now, you notice you see that label yolk sac. That is named that strictly from evolutionary ignorance and arrogance, because it never contained yolk. But this was because of the assumption of going through these animal stages, fish to amphibian to reptile to mammal to person, which never happened. So its proper name is the umbilical vesicle. The umbilical vesicle. And this is the first site of the production of blood cells. So that's where blood comes from, so that heart has some blood to pump around by 6 weeks of development. But now we're going to focus on the placenta itself and the layers and what they do. So I put this black oval here. We're going to focus on that and look at that in more detail. So there we are with those syncytiotrophoblasts, the white area, and the cytotrophoblasts, that top more purplish area, one cell thick on the very top there. And inside in that blue area is where the baby is going to be developing. And then the red represents the arteries of the mom inside that lining of the uterus, the endometrium. And so now these cells are going to be multiplying and invading. And so as they invade, it's like an army forming columns that are just going to go deeper and deeper. And this is happening because there is biochemical messaging going back and forth between the cells of the mother in the lining of the uterus and the cells in the developing placenta. And the mom's tissue cells are saying to the placenta, invade, come, take over. It's amazing. Invade, come and take over. And come in deeper, invade further. And so these cells keep multiplying and they're forming these advancing columns. And they're going to carry out two different functions as they get further down, and you'll see what those two functions are. So it's just amazing how these things keep happening, and this keeps going on so that it develops like this and keeps going on and keeps going on until finally it gets further on, and now you see that there are these little lakes, they're called lacuna, just the Latin for lakes, of these fluid in these regions here between these columns as they invade. So now we're just going to focus in on just one of these, and this is going to show you how the blood vessels develop and how there's going to be the interaction between the blood vessels of the developing embryo and the blood vessels of the mother, the fluid in the blood of the mother in the uterus there. So vascular refers to blood vessels, so the vascular development. So these are those advancing columns, and you see that white layer with the little dots. That, again, that's that zillion cell layer. That's one cell that surrounds everything of the baby and the placenta. It surrounds all of these projections. And so now these wavy lines that you see are the beginning of development of blood vessels. And so as they get further development, and there's all sorts of local hormonal activity going on, causing the development of these blood vessels. And so now you see I've used red and blue to distinguish between those that are going to become arteries and those that are going to become veins. And then as this development continues further, you see now capillaries at the end are developing, so that you're having a full network here of arteries coming in and veins coming out with capillaries there, so that when the placenta is ready, there will then be exchange of oxygen, carbon dioxide, nutrients, and waste products between the blood vessels in the baby and then the blood in the uterus of the mother. So as we look at the ends of one of these, two of these extensions, we see that one of them serves to act as an anchor. It comes down, and on the left-hand side, you see these cells multiplying further and further, and they're going all the way down to the muscle layer of the uterus to anchor, so that this placenta will stay anchored and not separate and cause the death of the baby. On the right-hand side, you're seeing that these mothers' arteries that are in there, and they're spiral shaped, these spiral arteries of the mothers are being taken over by the action of the developing placenta, and they are straightened out and they're plugged off so that they don't bleed until it's time for blood to flood the baby's projections of the placenta. So you see on the left-hand side that the anchor has formed, and of course there's many of these, not just this one. This is just a representation of these anchors, so that the placenta is firmly attached and won't rip off, which would cause the death of the baby. And then what happens is, at the right time when the placental development is finished, then the cells that are plugging up the mother's blood supply, the arteries there, are removed, And now the mother's blood is bathing these extensions of the placenta, so that now there can be exchange. No longer is everything happening just by simple diffusion. Without the placenta, now the placenta is in full action mode and is able then to handle the job of doing this work for the baby as it gets bigger and bigger and bigger, because when it gets to a certain size, simple diffusion by itself isn't adequate. It can't reach the whole organism. Too big. So, but now with the heart beating and the blood vessels developing now, nutrients and waste can be shuttled back and forth as the baby gets bigger and bigger. Does this not astound you? I mean, this is literally mind-blowing. Absolutely mind-blowing. And how anybody can think this happened just by itself, by random chance events, they're not using their God-given brain. So here we see the larger picture with the brown representing the muscle layer of the uterus, the womb, and then the lining, decidua, meaning the lining, and then you see there's a developing baby inside there, surrounded by the fluid, and there's a big plug of mucus down at the bottom of the uterus where it says cervix and cervical mucus plug. The word cervix simply means neck. This is the neck of the uterus. Okay, so we use the same word cervix for that as the cervical here. Cervical here for the neck up here. So as the developing baby gets larger and larger, the uterine cavity gets more and more filled, and the cavity part gets smaller and smaller. So here you see the baby getting to a significant size now, and the amniotic fluid is the pool in which the baby can move, because the baby needs to be able to move arms and legs and to have some motion there for those muscles. And then here you see the representation in that purplish color of the placenta with the extensions going into there where the exchange occurs between the mother's blood and the baby's blood vessels. So now we're going to look at how the placenta functions as different organs do in the adult form after birth. So first we'll look at how the placenta works as a set of lungs. So as I mentioned earlier, all of these earlier phases, everything is by simple diffusion of oxygen diffusing in and carbon dioxide diffusing out until that plug is released, and then we have the mother's blood bathing the thing. So here it is before the plug is released, and now after the plug is released. So now this represents the pink red representing the mother's blood bathing all these extensions that you saw. And so if you count the layers there, there's only 3 cell layers between the mother's blood and the baby's blood. 3 layers of cells, that's it. And so the mother's blood is not supposed to mix with the baby's blood. And again, it goes back to the genetics, because they have different genetic material because of the dad's contribution. And so the mother's immune system causes problems if there's contact, and we'll get back to that in a bit. So here in this situation, the oxygen is going to be diffusing from higher concentration from the mother's blood to the lower concentration in the baby. So the baby's blood picks up oxygen, and the carbon dioxide diffuses out from the baby to the mother, for the mother's blood to pick up the carbon dioxide, to take it to her lungs, and then breathe it out of her body. And so each of these particular cell membranes, what defines the borders of a cell, are made up of 2 layers of these special kinds of cells. They're a type of fat cell, and those are what make up those membranes. So the oxygen is able to diffuse right through that, and the carbon dioxide diffuse right through that, because those are non-polar molecules. They're what we would call fat soluble. And so they can freely diffuse that. No work has to be done, no energy has to be expended for the oxygen and the CO2 to diffuse through those cell membranes, through those 3 cell layers. And so what we have then is the ability then of the red blood cells inside the baby to pick up the oxygen and take it around. Now, you notice the shape of these red blood cells is kind of like a hockey puck that has been mashed in the center on both sides. We call this a biconcave disc, concave because it's pushed in. And you may ask yourself, why that particular shape? Why not just a perfectly round cell, a sphere, kind of like a basketball? Well, this turns out to be the most efficient design for maximum surface area for exchange of gases taking up the minimum volume, so that it's easier for these shaped cells to go through those small capillaries and to be able to flow more easily and to get through there and do maximum work taking up minimum space. And so inside those red blood cells and all the cells that we have, there is something called a cytoskeleton, meaning cell skeleton. Now, the skeleton of our whole body is bone and made up of minerals and proteins. But the skeleton inside the cells, those are made up of 3 different kinds of proteins. And so those proteins form the skeleton inside the cells that gives, in this case, the red blood cells this biconcave disc shape, this hockey puck kind of shape. So again, that's another, out of a zillion times I could say, how did this come about by random chance events? This had to be highly designed engineering. And so when we look at the molecules inside the red blood cells that carry the oxygen, the hemoglobin, it's set up so that the type of hemoglobin that the fetus has, the embryo has, and then later on the fetus has, is a different kind of hemoglobin than we have as adults. And that's on purpose, so that because that way, that kind of hemoglobin is taking the oxygen more avidly than mom's hemoglobin, so that mom's hemoglobin gives up the oxygen so that the baby's hemoglobin will take it. So those are different kinds of hemoglobin. And so the mother's hemoglobin likes the carbon dioxide more, and the baby's likes the oxygen more. So that's how that exchange of letting go and giving up and taking the carbon dioxide and the water goes back and forth. Well, how many types of hemoglobin do we have? Actually, there are 5 at different stages of our life. Those first 3 small short lines you see down in the bottom left corner are 3 types of embryonic hemoglobin, and they're designated by these different Greek letters representing the different chains of hemoglobin that are in them. So one of them has 2 alpha, 2 epsilon, one of them has 2 zeta, 2 gamma, and the other one has 2 zeta and 2 epsilon. And God designed this because of the changing conditions. As that embryo is growing, the acid-base balance changes, the pH, we call it, changes, and that affects the affinity of the oxygen with the hemoglobin. So as the conditions change, as that embryo grows, the different kinds of hemoglobin are necessary to be able to continue to do that exchange with the mother of the oxygen. Well, as it gets bigger, then we get to the fetal kind of hemoglobin. As about 10 weeks, then they call it a fetus rather than an embryo, and fetus simply means little one. That's what it means, little one. So now it has 2 alpha chains and 2 gamma chains. And so you see that line, when you get to the green line, birth, then after that green line at birth, then that fetal hemoglobin starts to drop. And then this other line, the adult kind of hemoglobin with 2 alpha chains and 2 beta chains, becomes the predominant kind. About 98.5% or so of our hemoglobin as adults is the adult form. We still have a minuscule percent of the fetal kind there that persists. So these different kinds of hemoglobin are needed for the different kinds of conditions as the embryo and then the fetus grow, and it becomes the adult form at birth. Now, where is this stuff made? Well, I already mentioned that the first location of blood formation is what is historically and incorrectly, erroneously called the yolk sac, which should be called, and the current medical literature is called properly the umbilical vesicle. Vesicle meaning just a small sac, vessel, sac. And so you see that represented by that pale yellow coloring at the very top of the slide there. So then, as the baby grows, then the position of manufacturing of the blood cells changes to the liver. I'll bet you didn't know that as you're developing, the liver then takes over the job of making the blood cells. And that's represented by that pink zone. And then after that, the spleen gets involved. And a lot of it is simultaneous with the liver. And then finally, when the baby has grown enough and developed enough to have bones, then the bone marrow takes over, as it is in us, to be the site of formation of the blood cells in that pinkish, darker pink, salmon-colored region there. And so the bone marrow then takes over as the final, ultimate place of red blood cell formation. Tell me how that evolved. Yeah. Okay. All right. So all of that's involved with the placenta functioning as lungs, getting the oxygen and the carbon dioxide dealt back and forth. What about functioning as the liver? Well, the liver does an amazing number of things, thousands of different things. And I think maybe that's why it's called the liver, because you can't have life without the liver because of all the different things that it does in terms of chemical reactions that are necessary for the body to function. Among these, and I'm just listing a few things, just a tiny examples, are dealing with bile salts. You know, bile is what is held in the gallbladder and is released into the digestive tract to help digest fats. Well, the bile comes from the breakdown of the red blood cells of that heme in the hemoglobin, the heme. And so you see there a representation of the cholesterol molecule, which is from which the sex hormones are made, the androgens and estrogens and other hormones as well. So it also deals with this breakdown of the red blood cell, as I mentioned, and two of those are called bilirubin and biliverdin. And if someone has liver failure, the liver can't deal with the bilirubin, and you turn yellow. If you ever see anybody who's jaundiced turn yellow, it's because their liver isn't able to function adequately. And so there's a representation of the hemoglobin, and from that, this is the heme portion. That's where the oxygen is carried on that iron atom in the very center of that heme part. So that's not actually part of the protein. The globin is the protein part of the hemoglobin. So it's that heme part that's broken down into the bilirubin and biliverdin and also converted into bile. So that stuff is recycled and reused in another manner and by a totally different organ system. That's what you call efficiency of design. And then xeno means foreign, so the liver also deals with metabolizing foreign molecules, xenobiotics, foreign molecules such as prescribed drugs or maybe illicit drugs or alcohol, those kinds of things. So all of those things are processed by the liver as well. And then industrial chemicals. So somebody is exposed to some industrial chemicals as part of their work, and they get exposure to them, then the liver deals with those things as well. What about the GI tract, our ability to take in food and get the nutrients? Well, as I mentioned in these earlier stages, everything is by diffusion. Even before the egg is released, and the egg is still in the ovary, diffusion is how that egg is fed. You see the artery there up in that corner, that red pitchfork-looking thing. And then the secretions in the lining of the abdominal cavity as the egg is getting to the fallopian tube, to those fimbria to get it into the tube, and then secretions in the fallopian tube and secretions in the uterus as well are nurturing this. But the egg itself is so small, and then after it starts dividing, it's still so small that that simple diffusion is adequate. And then even while it's still in these very early stages, as invasion into the lining of the uterus takes place, simple diffusion, until the placenta is then developed adequately at the right time then to take over the job. So these are all done by simple diffusion until the umbilical cord and the placenta are then developed and take over the job. So here again we're showing that interaction there between the mother's blood and the capillary of the baby there. And so sugars, for example, need to be transported into the baby. So here's the representation of a sugar molecule there. That little thing that's black, looks like a broken twig. And then outside on the cell, remember I mentioned the membranes of the cells, there are these special proteins in the membranes of those cells that are responsible for transporting those sugar molecules into the cell. So all the stuff that gets into and out of the cell is very carefully controlled. Tell me how that evolved. And so there are these sets of these transport proteins. These are proteins. These are molecular machines that do this job of transporting the sugar into the cell. All right, so there you see the white box around that protein represented there by that green shape. And we have then the representation of that sugar molecule needing to get in, and then it gets into through the cell. So it's transported across all of those 3 layers of cells through those different transporters to finally get it into the baby's blood. So it has to be transported across 6 cell membranes to get into the baby's blood. Okay, so there we go. So we go through this from outside to get it inside. And so there are different kinds of these sugar transport machines, molecular machines represented by these different numbers. And you see here those little tiny green ovals in those black lines. The black lines represent the membranes of the cells, and the little green ovals represent the transport molecules, the sugar transport molecules. GLUT, referring to glucose transport, and so there are different kinds for these different places to do their work. What about amino acids? The baby needs amino acids to build proteins. So it's the same thing. There are these various, and this time I use purple for protein, to show that in the membranes, you see in the black lines on the far right there, are these various types of molecular machines that transport the amino acids into the blood through these 3 layers of cells. And fats. Baby needs fats for energy to fuel all of this molecular work that has to be done. So this time I used orange to represent the machines, the proteins, the molecular machines that transport those different kinds. You can see there's a whole bunch of different kinds of fat molecules, and they each have very own specific places, specific jobs, tasks to do. And so the various types of the fat transport machines deal with these as well. So that's how the baby gets its nourishment. Well, how about the kidneys? The placenta functioning as kidneys. Well, so then the placenta has to control fluid circulation. Now this baby is floating in this amniotic fluid, but there is exchange of fluid and stuff in the fluid between the fluid and the baby. And there's also fluid that's manufactured in the lungs that then flows out of the lungs through the throat and out the mouth into the amniotic fluid. So all of that has to be controlled as well. So the amniotic fluid is a mixture of a lot of different sources of fluids. And then fluids from the kidneys. When the kidneys finally still become mature enough to start functioning, then the baby is urinating or peeing into the amniotic fluid as well. So all of this stuff has to be dealt with, and then the wastes have to be transported to the mother to get rid of, for her to excrete through her kidneys. Mom has to do a lot of work, lots of work. So mom not only gets to eat for 2, she has to work for 2. So lots of work. So there's turnover in the constituents of this amniotic fluid. And so the placenta regulates all of this stuff so that everything is in proper proportion and removal of the waste products. Well, more specifically in this sphere is the business of transporting water and minerals to make sure there's the appropriate amount of each of these different types of minerals, and there are more than what I've listed here, but these are the more basic ones. And so there are these various machines, again, in these cell membranes that regulate the flow of these different kinds of minerals, and they are specific, a particular type of machine for a specific mineral. One for potassium, one for calcium, one for magnesium, etc. I wonder how that evolved. Placenta as endocrine glands. Okay, so we have lots of different kinds of endocrine glands, lots of different kinds of hormones that do lots of things, and they affect different parts of this whole system. So I'm going to break it down this way. Hormones that affect the mother as a whole, her entire body. Hormones that affect the uterus itself, the baby's home. Hormones that affect the placenta itself, that's doing all this work. And then hormones that affect the baby, the fetus. So there's all these different kinds of hormones going on. So I already mentioned progesterone. This is the one that keeps the pregnancy going. And this is the one that keeps that lush membrane supporting the pregnancy nice and lush instead of sloughing off. So its effect on the ovaries is to suppress ovulation, suppress release of another egg, so that the mom doesn't get pregnant again while pregnant with this particular person. And then it affects the pituitary, which is a small gland at the base of the brain, which deals with lots of different kinds of hormones, suppressing what's called luteinizing hormone, which is in the effect is on the ovary, again, to say to the ovary, okay, we're going to put everything else on hold. And then the estrogens, so those affect the mom's breast to prepare for producing milk for lactation, and also the changes in the birth canal, so that when it's time for the baby to leave the birth canal, the uterine muscles will be able to be ready to constrict, and that the cervix will be ready to relax and widen. Or I shouldn't say relax, I should say be able to be stretched. There's nothing relaxing about this. Oh, that reminds me. When my kids would get too hyper, but something I would say, lax and relax. You know, cool it. And also, there is in the front of the pelvis, I should add this picture here, but in the front of the pelvis, there's a set of connective tissue between the two bones, and that connective tissue has to be able to become soft and stretchable, so the bones in the pelvis can be stretched apart so the baby can get the heck out of there. All right? So that's another effect there. That's part of the preparation of the birth canal. Remind me to add that picture, please. And then there's human chorionic gonadotropin, big, long name. And what this means is it's a hormone made by people that affects the development of the gonads, the sex organs, and makes them grow, and it comes from this layer called the chorion, part of the placenta. This is the hormone that is used for that pregnancy test. You look for that little blue stripe on that gizmo, and that's what that hormone is. So if that's detected, that means there is a pregnancy, that fertilization has indeed taken place. Okay, again, affecting the mother, human placental lactogen. So this is telling the breast to start getting ready to make milk, not only to grow, but to actually be able to produce milk. And then another one telling, placenta is telling growth to occur in general, adjustments to the pregnancy. Mom has to have all sorts of changes in her body to make stores in her body of sugars and amino acids and other things available to the fetus, the developing baby. So if mom doesn't have adequate nutrition and is not getting enough of everything for her and the baby takes what it needs. It will get what it needs, and mom gets the short end of the stick. So that's why it's so important for mom to be able to get all the nutrients she needs, because she loses out if there's not enough. And then these two deal with changing mom's metabolism, telling her thyroid gland up here in the neck to go into higher gear to increase its metabolic rate, because it's controlling the rate for two people, not just one. And then corticotropin deals also with the adrenal gland, which sits on top of the kidney, and it makes 3 different classes of hormones. So you have hormones dealing with increasing other hormones that affect mom, so that her body is in optimal shape to support that pregnancy. Then we have these other kinds of proteins that are hormones instead of the steroid type hormones. These are protein type hormones that will break down uterine tissue, preparing it for the birth process. And then progesterone, as I mentioned, inhibits contractions so the baby is not pushed out too early, and keeps that decidua nice and lush and supportive. So there we see again that effect of the progesterone keeping that nice and lush and supportive. And then there's a bunch of other ones that we won't go into detail, but they're involved in the birth process. That's a whole separate talk, which someday maybe I'll put together. Here's a picture of some of them. Okay. So much is involved. Can't imagine how this happened by random chance events. Well, what about the placenta making hormones that affect the placenta? Yes, this is going on. All right, so we mentioned the business of these cells fusing together to form that super mega cell which surrounds everything of the baby. Okay, that's one of them. And then another hormone that the placenta makes, telling the placenta to grow and develop. And then I mentioned to you how those blood vessels form, so there's special hormones dealing with the formation of all those blood vessels. And all these others that have zillions of different functions, but a lot of it is dealing with blood flow in the placenta, controlling that. And then we have this business of acetylcholine, and it says non-neuronal. Acetylcholine is what we use in many of our nerve and muscle junctions, where it's a chemical transmitter to get the signal from the nerve to the muscle, telling the muscle to contract, or from the nerve to the second nerve in the series. This is acetylcholine, same molecule, but a totally different function, nothing to do with the function of the nerves. Instead, in this situation, we're talking about acetylcholine dealing with telling the cells to multiply in number and to become different kinds of cells and to migrate and move from one part of the body to another. For example, the cells that form the inner part of the adrenal gland, called the medulla, which is very different than the cortex of the adrenal gland, the outer part of that gland. The cells in the medulla come all the way from the brain. They grow down. That's why there's this nerve connection from the brain to the adrenal gland. So that's why if someone were to show up all of a sudden with their machine gun or something and scare you, your adrenaline pours out. That's because there's that instant connection from brain to that gland. It's there right now. Boom. It's not like the other hormones that go through the blood and get to where they need to in a matter of minutes, and then a response in a longer time frame. It's like boom. That's how you get that fright or flight, fight or flight response in the fright with the adrenaline. Or you get cells that migrate, for example, the location of the testicles. They start up where the ovaries are in the woman, but then they migrate down into the scrotum, the sac. So that's a lot of migration there that goes on. And then cell-cell contact causes different kinds of things to happen, causing cells to differentiate into different kinds of cells. We have over 200 types of cells in our body, and the number is in dispute because actually we're still finding new kinds of cells, even today. Actually, even more in the brain that we never knew about before, and other places. So that's why the number is in change and in dispute, but somewhere maybe 220, 230 different kinds of cells. I mentioned the cytoskeleton, that protein skeleton inside of cells. So all of this stuff is affected by this acetylcholine. And so here's just a picture giving you an idea of the orange representing and the purple representing and the yellow representing those three different kinds of proteins making up that skeleton inside the cells. It's amazing, absolutely amazing. Okay, how about the placenta affecting the baby as a whole? So estrogens, we have to have protection so that there's not too much of effect of estrogens on the baby, so it's at the appropriate level. And all these other things, this human placental lactogen, dealing with the secretion of milk by the mother, also has these other functions in the baby, dealing with insulin and other hormones. Surfactant is what's inside our lungs to keep those alveoli open, those little ends, grape-like clusters at the ends of the airways, open so that they don't collapse when you breathe out. And so that's just one of the other things that is involved here. You could see that on many of these slides, we could go into so much more gory detail, the goriest of detail, but we'd be here all year if we did that. Okay, now here is the uterus being in the endocrine gland affecting the placenta. Remember I said that there was biochemical communication back and forth between mom and the developing baby. So these are things that the placenta makes affecting what's going on in the, the uterus makes going on that affect the placental development. And so just one of the obvious ones here, vascular endothelial growth factor, vascular, the blood vessels. This is one of those things telling those blood vessels to develop even further. And let's have you do some more invading here, taking over the uterus. And then the placenta as a protector in many different ways. So there is that basic diagram here, and that amniotic cavity is a bathing fluid. Well, it protects in various ways. It's a cushion against external energy. Let's say mom's driving along and has a super sudden stop, and so her belly hits against the steering wheel, or maybe the seat belt is all of a sudden increased pressure. So that abdominal fluid provides, amniotic fluid provides some cushion there for physical buffer protection. It also helps provide protection against the pressure when the uterus is contracting to push that baby out, so that the baby isn't squeezed too much. Also provides free space, as I mentioned before, for free movement of the arms and the legs. Very interestingly, they've discovered that identical twins have different fingerprints because of the differences in how their fingertips have touch and pressure inside the womb during development. Isn't that something? Stable fetal temperature, so in order to be able to get rid of excess heat, if mom has a fever, then that fluid is able to diffuse out the excess heat, and so the baby doesn't get cooked. And then placenta provides a barrier against most bacteria, protozoa, and viruses. There are some that do get through and cause serious disease. Maybe you've heard of the Zika virus, where the babies have these tiny little heads. That's one of the ones that can get through. There are others as well. And then this business, as I mentioned, the baby is genetically different than mom. And there's this huge, complicated system that is there to keep the mother's immune system from rejecting the baby at all stages. Because otherwise the antibodies would be attacking the baby. And this happens with the business of the Rh factor. So when an Rh negative mother has an Rh positive baby, because dad is Rh positive, there's the possibility of mom developing antibodies that will affect not that pregnancy, but a subsequent pregnancy. And so this is why pregnant moms who are Rh negative are routinely given something called RhoGAM, which is to prevent, to block the production of antibodies that, so that the subsequent baby, if is Rh positive, won't be affected. There was one case when I was in training where unfortunately in the mother's medical record, someone had written Rh, didn't write out NEG, just put a negative sign, like plus and minus in math. And somehow that got changed to a plus. So the mom did not get RhoGAM. And so in the subsequent pregnancy, her immune system attacked that subsequent baby. And this showed up on the ultrasound. And so the physicians were able to give mom and the dad the announcement prior to the time of birth that that baby would not survive. It would, more than maybe an hour or two after birth, and that would be it. And that's exactly what happened, because I was there at that birth. So again, the business of the immune system, even the sperm have to be protected from mother's immune system, or mother-to-be's immune system, because these are foreign objects, they're different genetic material. And in the movement of the zygote, after the egg and sperm unite, through that fallopian tube has to be protected against mom's immune system. So this is not part of mom's body to be disposed with at her will. Okay. So through all of these stages, there has to be protection against mom's immune system. And even when this invasion is going on, there's the chemical invitation to invade, but there has to be keeping mom's immune system at bay as well. All of these stages, same thing. And it's throughout the entire pregnancy, this whole issue that mom's immune system has to be kept under control. Again, how does that happen? By random chance events. So then, with the circulation, remember I mentioned this business of this one megacell that has millions of nuclei in it surrounding the baby. Some of those nuclei make their way into mom's bloodstream. Some of those nuclei make their way into mom's bloodstream, and yet it doesn't cause a problem. Now, in thinking in a different way, mother makes and dads make different kinds of antibodies to attack viruses, attack bacteria, to attack protozoa, all these things, in fungi as well. One of those is called IgG. There's also IgM, IgA, IgD, IgE. IgE is one of those kinds, and so mother has IgG antibodies against various kinds of infections, like if she's had a strep throat in the past or been exposed to different things, mumps, etc., all these things that a lot of us get. She has these IgG antibodies, and they cross these cells, these 3 layers of cells, into the baby's blood for the purpose of giving the baby protection after it's born. So that for about 6 months after birth, the baby still has a fair amount of protection as its own immune system is getting into gear and starting to crank up and produce antibodies. So that's called passive immunity. So the baby has about 6 months of passive immunity thanks to mom's IgG antibodies crossing the placenta so that they're in the baby at birth. How does that happen by random chance events? So all these different things, the circulation, the lungs, the liver, GI tract, the kidneys, endocrine glands, and acting as a protector. The placenta does all of this thing. That's why I titled this the Perfectly Providing Placenta. So the significance of all of this. Well, there's this concept called irreducible complexity, which means you have a system, and this can apply to any system. You can only simplify it to a certain degree, and beyond that point, if you take any one thing out, the system can no longer function. A simple example often used is a mousetrap. Mousetrap has 5 parts. You take any one of those parts out, then you have a piece of junk on your hands. Okay? Now, the 6th part, a piece of cheese, that's optional. It makes it work faster, but it'll still function without the cheese. But the hammer and the spike and the spring and all that stuff, the platform, all that stuff is necessary. So this is a phenomenal example of irreducible complexity with all these thousands of things the placenta does. We aren't even talking about the birth process. That's a whole nother topic. So there's no way this manner of entering the world could have evolved. So we have an often quoted verse here, Psalm 139, 13 and 14. For you formed my inward parts, you covered me in my mother's womb. I will praise you, for I am fearfully and wonderfully made. That's where most people stop quoting this. But I think it's important to keep going because it says here, marvelous are your works, and that my soul knows very well. So what this means is that all of us have this knowledge that we were created by God, but some people go to exquisitely great lengths to suppress that knowledge and to deny it. My frame was not hidden from you when I was made in secret and skillfully wrought in the lowest parts of the earth, meaning the uterus, the womb. Well, here we have a command. Do not be conformed to this world, but be transformed by the renewing of your mind. And that's what we're doing here tonight, is renewing the mind. And it's a command. It's not a suggestion. And the second command that goes in league with this is, but sanctify the Lord God in your hearts, and always be ready to give a defense to everyone who asks you a reason for the hope that is in you with meekness and fear. So this means when someone asks, we're to be ready to give the answer. Doesn't mean we're supposed to go out and pound someone over the head with the Bible. Okay, that's not the way to get their attention in a positive way. But if they're asking, then we must be ready to give the answers. And it says with meekness and fear. That means with gentleness and respect. Okay, so we do it with gentleness and respect. That's the way folks can be brought to the truth. So, another command, be ready, be sharp, like the cactus here. For this is the will of God, that by doing good you may put to silence the ignorance of foolish men. There's a big difference between smarts and wisdom. There are a lot of very smart people running the world who have no wisdom. Okay, they've been fooled by Satan. And they're very foolish people doing very evil things, as you have been witnessing. So we have this little pumpkin in the amniotic sac saying, questions?
Well, as I get ready to pass the basket around, I'll start off by saying that I have a very good friend I got acquainted with in Oregon years ago, and his mother and father had the same thing. He was the second pregnancy, and for whatever reason they did not give her the Rocam shot. He said he spent most of the first 6 years of his life in the hospital. At one point he was lying in a hospital bed and he had no pulse, but yet he was still alive. And these two interns were talking about him. It was like, how's this kid still alive or whatever? And he's like, hey, I'm not dead yet. Don't be talking to me like that. And anyway, he went through several things and many surgeries and stuff. And at one point they had to do something to his liver because his liver was atrophying just really badly. And and then the surgeon who did this